Thank you for joining. My name is Jason Hines, and I am CEO and co-founder here at Gigasheet. I'm joined today by Garth Griffin, our CTO and co-founder, and excited to dive into this and show some actual live demos and talk about how to view and analyze machine-readable files. It's interesting, Gigasheet, one of the first things we built early on is a JSON capability to look and interact with large JSON files in a spreadsheet-like user interface. And today that is still the backbone of a lot of what we do at Gigasheet, and you'll see that today. So thanks for joining. To start off, I thought we'd just do a little poll here and ask people a couple of questions about their experience working with machine-readable files. So hopefully you should be able to see a couple questions up on the screen, and I'm interested to see what your answers are. The first question is, what's your experience been with machine-readable files, or MRFs? Everything from you're an expert and you're very comfortable with it, which probably means you know how to write some code, all the way to I don't know what a machine readable file is, in which case we are going to find out very, very short order here. And the second question is, which type of organization do you work for? And those probably make sense. There are a wide variety of different groups and stakeholders who are using this data for all kinds of things. So we try to include those in this poll. So share some of the results with you guys at a high level, because I think you can't see this data, but it's not a secret. So 63% of people here have some success opening files and inspecting the data. Interestingly, no one is claiming to be an expert at this data. That's probably safe. And we have a few people who've attempted it and a few people who this is new. So that's perfectly fine. And we have a lot of people who, the most common group here today is consultants and advisors and business partners. And then we have a smattering of folks from the others, which makes sense, because what we're about to dive into, and we'll get a bit into the weeds here, this gets more technical, and is typically, when you get into the weeds of it, are things that we see technical partners helping out a lot with. And so today we're going to focus on that. We also will show you sort of the finished product that we create here at Gigasheet for our clients and customers, but we'll also dive into kind of behind the scenes and what goes on. And if you're interested, how you can do a lot of that work manually. So with that, I think we'll get started. So with that, what are machine-readable files? A few of you don't know, and I'm happy to educate you on that briefly here. I did not know what a machine-readable file was until we started working with healthcare data. Machine-readable file is a term that covers a number of different things. I had heard of JSON files, XML files, CSV files, but I think machine-readable file is sort of an umbrella term that captures all of that. What it means are data files designed for computers and software to interact with. It's not great for humans to interact with, is the key there, versus, say, a Word document or a spreadsheet is a very human-readable file. Specifically today, we're going to be talking about healthcare price transparency data and those MRFs. We're going to focus on JSON. Gigasheet supports CSVs as well. Most healthcare price transparency data is published in CSV or JSON. Increasingly, it's moving to JSON. XML, I have not seen much of that data out there, and generally, we're not focused on that in this webinar.
I just want to interject on what it means, the machine readable file. The really key thing is that they all follow a published schema. So that's I think that's sort of the intent of the machine readable aspect. Like if you're writing it for a human, you can write a document with paragraphs or headings or whatever. The machine readable files, they CMS has the law sort of specifies a schema, a structure for the files, and then the people who are producing these files are supposed to comply with that schema. And they largely do with some, whatever, some challenges here and there. But that's sort of the key thing is that you know in advance what the files are going to be structured, the structure of the files, so you can, browse that schema and decide what you want to do with it and how you get the information out. So I think that's kind of a key point about the machine readable sort of definition.
Yeah, it's a great point. Um, like Gar said, CMS, today we're going to talk about these machine readable files for price transparency. Gigasheet can process many other flavors of JSON as well. Um, and the reason we're talking about this is, CMS has mandated that transparency and coverage in hospital price transparency data be published in these approved schemas, which we'll dive into. So let's talk a little more about, well, what is, okay, so, today we're going to get really into the weeds, like I said, into the specifics and try not to stay at high level. When I see other people talk about this stuff, it just seems very high level, and I want to get my hands on this stuff. So today we're going to get a little dirty, and we'll see how that goes. This is what JSON looks like on the left. So if you've opened one of these files on your computer, this is kind of what it looks like, and it may not make a lot of sense, but really what it is a hierarchical structure. And the graphic on the right is a screenshot of how you could think of this being organized almost in this hierarchy. So it's actually not a tabular structure inherently. It's like this, where you have this organization structure. Now this is like the simplest form of an in-network file here that we're looking at, and this is made up data. But you have to imagine billions of rows of this that have to be sifted through, much of which is noise, to get to the answers that you're looking for. So this is what JSON looks like, and if you have opened it in a text editor on your computer, this is kind of likely what you're going to see. The whole idea behind Gigasheet and why we started this company, even from the beginning, was this idea that not everyone can write code and use databases or learn proprietary query languages, and they really shouldn't have to. It should just be a lot easier to use, regardless of the size or structure of the data. If it was in a simple spreadsheet, a lot more people could use it. There are almost 1 billion spreadsheet users in the world versus maybe 3 million data scientists or so. Now, AI is helping with this a lot, and we certainly use AI in our processes as well. But still, there's a long way to go to get to making this data more accessible, and that's what we're working on. The data is messy. When we saw people coming with these MRF files to Gigasheet shortly after the rule went into effect in 2021, the price transparency rules, and the data was frankly not workable, just corrupted or malformed files. Fast forward to about 18 months ago, the data has become much more usable. In fact, October 1st, CMS just approved a new schema that will be enforced, I believe, next February, and it improves the data further, we hope. We'll see how that goes. There's still a long way to go, and we'll talk about that. But all of the things that we're talking about today and what we're working on are trying to make this a lot more accessible and easier to put to work for a variety of different use cases in healthcare. If you've played with this data at all, which most of you have attempted it in some form, you should know that these files that are published by hospitals and payers are massive. They can be. Sometimes they're small, but it's not uncommon to run into multi-terabytes of data in these JSON formats. Or sometimes it will be manageable in terms of size, but you'll have to download, say, 6,000 different files and combine them together to get the results that you're looking for. So this data contains negotiated rates for payers and providers, but it also contains lots of rates that are not used in reality. These are called zombie rates. Classic example would be something like a rate for a chiropractor providing a heart surgery procedure. It's never going to happen in reality, but you'll find these kinds of rates in the price transparency data. You also find $0 negotiated rates or just irrelevant data where the NPI or billing codes are not formed properly. It's getting better. I will say that, but it's not perfect. So there are lots of duplicates in this data. That's one of the things that the new schema is hopefully going to help address. But I assume that there will still be some deduplication that has to be done at massive scale. And we're talking about billions and in some cases tens of billions of rows of data before it gets reduced down to what's usable. These fields are often inconsistent across payers. Like one payer may interpret a professional rate to be something different than an individual rate at another payer. The guidance on this by CMS is just sort of uh, leaves some ambiguity. So it can be difficult to make sense of at the end with all of these things here. So this is what we're talking about. This is an example we took just from Idaho, where we took the major payers across Idaho. I think it was maybe the top five payers in Idaho, and it was 1.2 terabytes of data and 32 billion rows. Idaho isn't exactly the most populated market. There's not as many providers in Idaho as, say, New York or Texas. So it just gives you a sense for this. Garth, did you want to talk a little bit about
I
some
just
of
think
the,
this
yeah.
is to me this is sort of the fun part. So I'm on like the technical side of things here. So to me this is the real sort of interesting puzzles of working with this data come in trying to take it from what they publish into something that's actually going to be interesting and analytically meaningful. So yes, 1.2 terabytes, a huge amount of sort of input JSON data. And even just to get that into the 34 billion rows, that's already a pretty exciting thing to try to do to make it sort of tabular in any way. But 34 billion rows, I mean, that's just nobody's going to be able to sort of browse that or, do things with that to get a business insight or to make a decision. So that's really only the first step is just to turn it into something tabular. After that, the second step is that middle bullet where we're talking about sort of the quality of the data. And this is where that zombie rates idea that Jason mentioned a minute ago, where that comes in. They're just entries that don't make any sense. They can't, it's not that it doesn't make sense for the particular question you're asking. Like there is no sensible question that would use these zombie rates. So the only thing to do with that, we got to just ditch them, get rid of those. And also there's tons of duplication. So across these files and, we could speculate about why that might be, but, there's no reason to sort of have to browse through repeated entries with exactly the same information. So we got to get rid of those. And then the last thing is maybe there's just mismatches and talking about providers that aren't going to be ever participating in a particular market. And we got to get rid of that as well. It's just going to end up sort of confusing, if you have prices for somebody that isn't really going to be actually providing the service, it's going to inflate the average or, change the outcomes. So that's the quality step. And this is like independent of whatever question or whatever insight, whatever analysis you want to do. There's a bunch of data in there that just doesn't make sense. And so that's that middle step is really just got to clean that up and get down to the ones that are sort of real or valid. And then the last one, sort of challenge is that there's all sorts of ways that these files come out, and so we need to normalize them. So we've gotten this kind of huge swath of data and removed a bunch of stuff that doesn't make sense and sort of cleaned it up. But now we'd like to be able to compare, for example, compare across payers or different plans or select different providers, different geographies. You want to be able to compare whatever kind of question you're trying to answer, compare different things in different ways. So we need to have it all very normalized. And you'd think that since they're machine readable files, they're already sort of supposed to be normalized, so they are in that sense. But after all this work has been done, we need them to really we want to stack them all up in one big sheet or however you're going to do it. And so that's the last challenge is around sort of the structure of these files, how they're published. There are multiple paths that are allowed through the schema. And so get those all into sort of one standard form was our sort of last challenge there. And having done all that, then you have the working data set that you can really sort of do analysis on. Now it can still be quite large. So in our example here, started with 32 billion or 34 billion, and we're down to 200 million after we do those steps. Now, 200 million, still a pretty sizable amount of data. You're probably not going to pop that open in Excel on your laptop, right? That's not going to work. So there's still, even at the end, after all of, after this 99% reduction in volume, it's still quite large, and you still need to sort of use good tooling for that, like Gigasheet, using it in our sort of very scalable environment. So even at the end, you still have to sort of think about the volume and use good tools for that. But at least then you know that the numbers you get out of it are going to make sense. They're, you could sort of confirm it, or you're going to expect to have, if you take an average or you do a comparison, you can be confident that you're sort of getting to a real insight and not just looking at the sort of noise that was such a huge volume. So those are some of the challenges that you find working with this data, and that's some of the work that we've done to kind of make this data useful or usable. The intent obviously is that this data is supposed to be insightful, right? That's the intent of the law. That's what the purpose is of requiring this sort of compliance to people publish these. And the truth is that you have to do a lot of work on them before you get something that you would call insightful, or something that really does help you make decisions or find more value or whatever you're trying to do. So I think that's a great, for me, that's what I get excited about. So those are some of the challenges that we see.
Yeah. And we should mention, like, there's one, they publish a schema or a definition of how this data should be published, but there are so many different flavors and forms of that. It's almost a misnomer. I mean, it does loose, I mean, it does generally follow the same structure, but when you get into it, and it changes it over time too. Like, we've seen some payers that'll publish 30 files this month, and then next month they'll publish three, and then the following month maybe 120. So I'm just kind of making that up for example purposes, but there's this variance that occurs in this, and all that has to be kind of sifted through. And of course there are these files pointing to files or pointing to other URLs, and again, it seems like things are getting better in the future, but these are just things to be aware of when you work with this data.
It looks like the new schema, we, like Jason said, we have to wait and see what really happens with it. But it looks like the intent with the new revision is to simplify it and sort of reduce the number of different paths that you can do through this structure. So, we'll see how quickly if that actually comes to be what's true, and if they comply with it and so on. So, we're stay tuned on that one. But I think that's sort of the thrust, the intent of the future direction here is to simplify it. So we'll see.
Exactly. So let's keep moving. We want to get into the hands-on part here. So a lot of people are using this data in a lot of different ways. It kind of started out, like I said, as unusable, and has become increasingly useful and solvable problems. And it still has imperfections. It's not a silver bullet for negotiations or research, but it is absolutely a new and valuable piece of the puzzle. I think we have a long way to go, but providers are using it to better understand where they stand in the market. Previously, this is opaque, and de-identified claims data was used in some cases, but not really able to be used in negotiations. Revenue cycle management on the provider side, this can be useful for integrating with RCM activities, for employers and benefit partners. So for self-funded plans, really here, if you're a self-funded employer or you're a partner of one and you're working with them and you want to help them, drive value-based care initiatives, steerage, or also just compare plans on the market, you can use this data for that to sort of shop around when it comes time for benefits review. On the payer side, we see lots of applications with network development and adequacy use cases, and then contract strategy, contract negotiations for when they're creating products to sell in the marketplace and sales support. For medtech, life science, device manufacturers, a lot of times it comes down to market access, just trying to understand what is out in the market today, what rates providers are getting to educate providers and provide better forecasts if you're bringing new products to market. this is not a comprehensive list. Lots of different ways people are using this data, but I thought I would highlight that. So let's get into it. We're going to show you two different offerings that we have at Gigasheet today, and maybe I'll talk about that first. So on the left, we have Gigasheet for price transparency. This you can think of as the finished product, right? Like we do all the work, we run it through lots of processes and filters and cleaning, and I'll show you what that looks like, what the output of that looks like. On the other hand, we have sort of a toolkit, which is more Gigasheet MRF Explorer. These are self-service tools for loading whatever data you want on demand and exploring it. It's not cleaned, it's raw. It comes right from the source, the payer or the hospital, and we'll look at it. We'll show you what that looks like today, and we'll process some data. It doesn't include any enrichments, so you're not getting like Medicare benchmarks or the full NPI data or details. All that has to be done manually. But if you're just looking at a very specific, one payer, one NPI, and certain billing codes, it is doable. It is very doable. If you want to do a broader market analysis across many payers, many NPIs, or organizations that have many providers, it's going to be more challenging. Also still doable. It just kind of depends how much work you want to put into this. So with our full offering, like this is kind of the full spectrum, everything from processing and loading the MRFs, we take care of that, adding the NPI details, cleansing the zombie rates, adding Medicare benchmarks, entity resolution. This list keeps growing. We're constantly layering on additional details from other data sources that are public or proprietary to enhance and make this easier to work with and more valuable. You can also join data in Gigasheet. So if you have lists or claims data or a comprehensive list of EINs or TINs or NPIs, and you want to cross-filter these large data sets, you can do that in our product. So really the MRF Explorer is primarily just this part of this spectrum. So let's get into it. Also, I'll pause here. If you have questions, just ask. Drop them in the Q&A panel. Happy to take those and answer them as we go here. So first, let's just look at, ultimately what kind of the end state is here. So this might be an example of that. Here, what we're looking at is a particular hospital in Minnesota. This is North Memorial Hospital, and we are specifically looking at billing code 99214, patient evaluation, typical office visit. And this is the query here that I've set up. So I said, North Memorial Healthcare is the name of the organization, 99214. I want to look at office visits, which is 11. And we add this smart rate heuristic here to remove outliers. And what does that look like? Well, I can tell you right now across these payers who is paying the most for this and who's paying the least. So if you're on the North Memorial Hospital side, you could see where you're best compensated and where you're least compensated. If you're on the payer side or the device side, this probably wouldn't apply for devices or medtech, life sciences. We'd look at a different billing code. But we can see here the negotiated rates, the Medicare rates as well, and we could flip and recalculate these by the average, let's say, versus the median. And you can see it's processing a lot of data because this is based on 292 million rows of data we have for the whole state for the major payers here. And we can inspect each of these groups and drill down to the individual rates below. Here I'm opening the group for Meritive. So we could drill in and see on the line item level exactly the negotiated rates and the percentages calculated here. As I scroll over, I can even see the individual providers, their practice location, as well as the EIN that they roll up under for North Memorial. And we also include the file name where we fetch this data. So for traceability reasons, you can always go back and see where the data came from. But you can very quickly drill down here and say, like, let's add an additional filter. So what I did there was I right-clicked and said we want to filter to this taxonomy code for family care, family practice type physicians, and say we only want to like drill into family practice providers and see what their rates are like. And you can imagine where you go from here. You could say, all right, now I want to flip and look at orthopedists instead, and I want to look at a total joint replacement CPT, or I have a whole list of billing codes I want to analyze. And this is the kind of stuff you can do when the data is complete and finished, and it looks like this. You know, it looks like a giant spreadsheet of several hundred million rows of data, and you can pivot and do all kinds of cool stuff. But let's work backwards from this and talk about how you get here. We talked about it on the slides, but let's take a look at, well, what can you do? This is if you subscribe to our price transparency solution. But what about that other case where you're looking for a tool set and you're willing to do a lot more of the manual work on your own? So let's take a look at that. And in this example, one of the payers you may have noticed in here was Medica. So I thought we'd just go look at Medica and what it looked like earlier in that pipeline and what it would look like if you downloaded data from Medica and loaded it into Gigasheet. Now, in this case, you can see there are a bunch of different Medica files that we had loaded here previously, and they're about 130 gigs each, and some of them are smaller and some of them are larger. We have our table of contents file here, and if I open one of these, like this PPO plan, you'll see it expands to 3 different files here. We have a file of 616 million rows of in-network rates. We have our provider references, which is sort of like that lookup table of all the providers. And then we have some metadata about when the file was published and their attestation. So if we pop these open, you'll see what they look like. And I'll show you, I'll keep going back up the chain and show you how to load this data. So this is all the rates. This is 616 million rows. And you can see this is raw, what it looks like when it gets loaded into Gigasheet. Looks very similar to the other data, but you'll notice the NPI details, EIN details are missing, and there are just these references instead of the NPIs, which is where this data comes in. So here we have a provider group ID, and then we have the NPIs, and we have the TIN data as well. So basically, this stuff has to be joined, which under normal circumstances is pretty straightforward, you would think. But because you run into this situation where there can be many, and there are multiple rows here for a single, it's not like a one-to-one relationship. It's a many-to-many relationship. So it is tricky, but it can be traced manually. For example, if you know the EIN, you could walk this back. Or if you know the NPI that you're interested in, you could do a point inspection of rates. And what you would do is come back to this file, filter this column here. You can use filters like you would in Excel to the rates, and then you would filter the billing code column as well. And you would also want to pay attention to the setting or place of service here. So that's an example of how it can be workable. And we'll keep going back and I'll show you, all right, so how did we get to this step?
Just want to make the point here
Yeah.
that the one in this form,
Mhm.
so the one that Jason showed at the end, all that work we talked about, the zombie rates and so on and so on. Jason's first most finished example, all that work is incorporated. In this level, you know, that in-network file with all those rates. Yeah, so this one, zombie rates taken care of. Um, in the one that Jason was showing just a moment ago,
This one.
this one still has all those zombie rates. So, you know, if you're doing the point inspection that's no problem because you'll probably choose, an NPI and a couple of rates that are relevant for them, a couple of, CPTs or whatever that are relevant for them, and that's going to be fine. But if you try to do sort of aggregations or so on that sort of this intermediate level with the raw files, that's where you're going to potentially run into examples where there's rates that don't really make sense, like knee surgeries done by chiropractors or things like that. So just want to make that point, this as you sort of Jason's kind of going backwards, right? From most finished product to intermediate and to more raw. So in this level, just want to make that point that, some of those data cleanup steps that we talked about, that's not necessarily applied at this stage.
Yeah, great. Um, Perfect. So this is kind of what it looks like in the raw form here. And yeah, if you have questions, please type it in the Q&A panel, and we'll be happy to address those. Um, I saw a couple questions coming in. So this is, like Gar said, this is uncleansed, right? This is very raw. And versus this, which is cleansed, and we have these views set up where we've done some analysis. Um, so you need to be aware of that stuff. But let's keep let's keep going um, back backwards and show you. All right, well, how would I even get to this point with it? Um, and what you would do is you would go out to the payer website, like in this case, this is Capital Blue Cross, and they have various hoops you may have to jump through at various times, or limitations on how much data you can download. But in any event, you can get the data, and this is one example of how you could do that. Um, and here we have their table of contents, and then we have some files, and I will grab one. So one thing you can do is just click download and download the data, and it'll come on your desktop, and then you upload it to Gigasheet, which is okay. Like in this case, this is pretty small. I picked this for demonstration purposes, and I can drag it in here and upload it. And it's zipped, that's okay. If it's unzipped, that's okay too. Gigasheet will process this. It'll be added to the queue, and you can see it's created a folder for this JSON, and now it's going to break out those various different tables there. So we'll take a look at this as it comes in. Maybe while it's processing, I'll take a couple of questions. Thank you for typing them in. So one question is, what kind of backend are we using to process the data so quickly? Thank you for asking. We think we have built the most efficient backend in the world for this. We did not set out to do that, but it's kind of where we've ended up. It's like the MRF life didn't pick me. I pick, or I didn't pick the MRF life. It picked me. Yeah, it turns out we built a very efficient JSON parser from the ground up, and we've adapted it very well to these files. The other thing is we do run on an open source data warehouse. I know a lot of people use things like Snowflake or Databricks, but we found in our, Garth, you should talk about this more, but I think it's in order of magnitude cheaper the way that we've done it. Some of that's proprietary, our intellectual property, but yeah, I don't know, Garth.
Yeah, we kind of just discovered that the JSON capability that we developed, we developed it for sort of folks whoever wanted to, had some random JSON file and wanted to look at it in a table. That was the sort of original idea of our JSON capability. And then we discovered that it was actually able to make sense of these MRF files with a little customization. So we did the customization and we're running the whole thing on it's a very scalable, very, sort of cost efficient and powerful, data warehouse that we built basically. So we're using open source technologies. It's not like we didn't write every line, but we've created this sort of back end warehouse system, and it works very well, and you can see the file sizes, like the row counts, we're in like hundreds of millions. Some of them are billions of rows. And you saw this. This is like not a pre-canned demo, right? Like these are Jason's just opening things up and clicking around, and you can see it's sort of ripping through them pretty quick. So, um, yeah. So I mean, I guess that's a little bit of a vague answer to your question. Some of it's proprietary, but that's sort of the story is that we had this JSON capability. We realized we could customize it for these and process them really efficiently and store them in our very scalable, sort of powerful data warehouse backend. So. Um, that's the story.
Yeah, I mean, and we customized it pretty heavily because we know we're focused on this kind of data, so we're able to make trade-offs, right? Like we don't have to worry about updating a shop. Like you would not use this to run a shopping cart system, right? You would not use this backend to do a lot of things, but it's great for analytics at really large scale, and particularly this type of data analytics.
I guess the deal I could share is we have the back end has it's like a two-part thing. So we have a columnar data store for the actual sort of file contents, like the rows and columns in there. And then we have a separate kind of kind of meta layer on top of that for like the organizational things or like which files go together and things like that. So I guess I say that the columnar data store, that's the really high performance thing. But we're not just sort of mapped directly to a single sort of database that way. We have this extra metadata layer where we can keep track of which things go with what or, other pieces of information about the files that we bring in. So um, I'll say that as well about it.
Yeah, we've been doing this since about 2021 is when we really debuted this system. So we've been working on this for years, and it continues to evolve. So here's the file. It did process. We got 9.7 million rows, a bunch of provider references, much like that Medica file, which was this one's only a few megabytes, whereas the Medica file is gigabytes and might take hours to process. I forget how long it took. But this is an example of a payer file, what you would get when you drop it into Gigasheet. There are also increasingly hospital files that are like this. This is the HCA Florida website, and I'll show you how we can process hospital files, different JSON format here. But let's grab one of these files and I'll show you how it will work. I'll show you an alternate way to load it into Gigasheet that often works. So I showed you how I downloaded it to my machine and then I uploaded it. But if you're dealing with like tens or hundreds of gigs of data, that's really inefficient. So often what you can do is right click and copy the link address here. You can also start downloading the file and pause it and go into your browser and get that link and go back to Gigasheet and go to new file upload. This is where you could browse your machine. You could pull it in from the cloud. You can also pull it in from AWS and even other pre-signed links from other cloud providers we also support. But you can paste in this URL from the HCA website and pull it directly to Gigasheet without downloading it onto a machine first. And this gets parsed a little differently. We'll talk about the hospital data and how it looks. Hospital data is interesting and useful in different ways. Generally, we're working with payer data, and there are a few reasons for that. One is the payer data is more voluminous, but in many cases that's more helpful because we want a broader look. Like we want to be able to look across the market, across lots of different things. The other reason is payers publish this data every month. Now, in reality, the data doesn't really change much month over month. I mean, you think about how often providers renegotiate contracts, it's not that frequent that they're adding, they're tweaking maybe their network, but a lot of these networks are legacy and been around for a long time and don't change very much. So the data is relatively stable and has a pretty decent shelf life. Certainly, I don't think, on the whole, when you look at averages and things or even medians, rates aren't shifting that much month over month. Maybe every quarter to 6 months is more, I think, more reasonable, but your mileage may vary and it sort of depends on your use case too. So This is processing hospital data. Hospital data is different. Hospital data does not suffer the same issues with zombie rates. That's not to say they're perfectly clean and that all the rates are exactly relevant, but you don't see the same kind of issues. On the other hand, hospitals only publish this data once a year. So data is, you know, like I think this data may be from 2024. I looked at it earlier and we'll see what it looks like now. But once it processes, we'll be able to take a look. The hospital data is not as detailed in terms of like CPT codes, and what it shows are provider. It shows the hospital's negotiated rates that they have with various payers. The interesting thing about hospital data is it does include Medicare Advantage plans where that is not required for payers to publish on their side. So this hospital file just finished. It'll take a second to load up the first time, and we can see here what it looks like. Similar to payers, there is a schema, but there are lots of flavors of this that are out there. So this is one example of how this JSON parses, and this is a more current JSON schema that we see more frequently. So you can see here we've got descriptions. We have different codes often. You'll see MSDRG codes in payer files as well as hospital files, but more so in hospital files. They have this code type, inpatient, outpatient settings. So it looks a little different. You can see they have methodologies, and they also have some additional notes here. So a lot of people who use the MRF Explorer are focused on hospital files because it's just easier to get your arms around. You can also drop in huge CSVs in here, like multi-million row CSVs, and it's very workable kind of on your own, do it yourself. So a lot of work can be done on the hospital files, and the MRF Explorer is well suited for that. In addition to some payer data analysis is possible, it just takes a lot more kind of rolling up your sleeves and doing the work. So that's a look at our MRF Explorer capability here, as well as kind of what you can expect as the finished product. Now we'll take a few questions. I see they've been sort of stacking up here as I've been rambling, and we'll take this. So let's see. How do you deal with zombie rates? Yeah, there are definitely some approaches that are out there. We do some proprietary stuff here as well, but the basic approaches aren't rocket science. So the basic approaches are to look at things like claims data and do a correlation analysis where you could see that, say, for example, we never see in the question that asks, the chiropractor doing knee surgery situation. If you look at de-identified claims data, you can and run a correlation analysis. It's like very close to 0 times, probably 0 times that somebody who's a chiropractor, their primary taxonomy code from their MPI is chiropractic doctor, then they're never billing knee surgery. Like, you don't see that, right? So using statistical correlation, you can weed out, you can basically create these pairs like this taxonomy code for this MPI. Yes, we have seen people bill for that at some point in the past, so therefore we include it, versus pediatricians don't do heart surgery, so no, they should be excluded. We keep all the data around, so we can always go back and like pull that in, but frequently it is not, rarely do we do that, but we have on occasion. So that's a high level approach. I mean, we are also using AI as well to do further reduction of this, like looking at outliers, doing detection on those outliers. Is this a type of procedure Medicare reimburses? And applying AI to this to do things like, does anybody get a colonoscopy in an ambulance? No. So, that rate's not relevant. So that's a little bit about how we do it, and it's an
I think
important step. Yeah.
I think it's worth pointing out we actually do it sort of in two stages. So, and we use Medicare data as one of our ingredients for this, or like the things that Jason's talking about there. But there's like the removal step where we get rid of ones that are just it's really just inconceivable. Like the chiropractors are not doing knee surgery. Like no, you're not getting a colonoscopy. And like we get rid of ones that like that's just not it's not possible. Um, so that's sort of the removal step. But then we also have in the sort of the polished outputs, sort of that first example that Jason showed, we have our we call it smart rate, but it's a sort of an analytic layer where we say these are the ones that probably are happening often, or these are sort of the more normal, quote unquote, more normal or standard or conventional, sort of cases for a particular billing code. And, that's usually a good starting point to say, like, look, if you're looking at pediatricians, like you can use the smart rate filter and get sort of, a standard kind of thing. Um, but there may be rates that are still included that are not part of the smart rate. So these are rates where it's like, yeah, they could in a special situation, maybe they have done this some procedure or another. And, so there's kind of those two filters. One is the ones where it's just really not even worth considering and we just throw it away. And those are the sort of ones we really would call a zombie rate. It's just not at all within the realm of possibility. We just throw those out. But then the smart rate is like, well, you want a sort of a starting point on the standard thing. You start with the smart rate, and then, maybe you have a particular analytical scenario where you want to include ones outside of smart rate, go a little broader. So I just want to make the point we sort of do it in two cuts.
Right. Right. So, like, here's the smart rate field that we have here, and it's just a binary, like true false. Looks like I need to refresh my browser here, but basically you can apply that heuristic to it there. Um, let's see, there were other questions about like, can I export this data to my machine? Yes, you absolutely can. Like you just go to File, Download, Export CSV. And if you want to look at it in Excel, you'll need to split it because Excel taps out around 1 million rows on a very powerful desktop or laptop. So you'll want to split it that way. You can also filter data and then export just that filtered data set. Questions that we have here are, does the cleanup of the zombie rates happen when the file's uploaded? No. So no, when you're using the MRF Explorer, it does not do any cleaning. And it doesn't happen on demand like when you load the data. So when you use MRF Explorer, it just parses what's in that file, and you get everything for better or worse. That is something that is included with our price transparency offering, where we do all the preparation upfront in advance for you. So that's how that works, and it's like they're two distinct offerings. Yeah. People are asking about the recording. It will be made available. We will email everybody who registered a link to the recording. Happy to do that. So don't worry. Also, feel free to reach out. Happy to sit down one-on-one with people, talk about specific use cases. This is what we do. All week, every week is work on this data, talk to people about ways they can apply it, what we've seen work before, what doesn't work, where the shortcomings are, how it can be combined with other data sets. Happy to do that. The pricing structure to process JSON and CSV and download it. It's not by the megabyte. It's an annual subscription service, and you get a quota. So you'll have a storage quota. That means that you can process up to a certain size file for that price, and you can do it multiple times. So you could do like 100 gigabytes, 500 gigabytes, terabytes, and so forth. So that's generally the pricing structure. Happy to get into details more, but not in this setting. So let's see. Let me see if I think I answered all the questions there. Any other questions? Feel free to reach out if you do have other questions afterwards. Thanks, Garth, for joining today.
Yeah, yeah.
And, thanks for the questions. It's always great to hear from you. And like I said, feel free to reach out. You can drop us an email at sales@gigasheet.com, and we'll get back to you. Thank you. Have a great day.
Thanks, everybody.